Okay, so now I have my data here. I now going to calculate some descriptive statistics. Okay, so I'm gonna do the mean, mean, the mean, median, the variance, the standard deviation. Now I'm going to calculate these four from the data. Okay, and later I'm going to calculate these four as well from the table. Remember that in some situations we don't have the data but only the table, and we need to be able to estimate these descriptive statistics from the table. Okay, we're going to do both ways and then we're going to compare the results. So the mean is the average. So I calculate the average. The average is 3.24, so $3,240,000 is the average salary of this sample of basketball players for the season 2000-2001. We know that the data is highly skewed, so let's calculate the median. Okay, so median now is 2,200,000. So you see the difference between the mean and the median is actually pretty big, right? It's 1 million. Now let's do the mode here. Now sometimes the mode, the distribution is multimodal. So that's why I have this apart. So the mode. Okay, so I'm going to use the mode mult. Okay, just to identify if I have a multimodal data set. So extend this and I'm going to recalculate. So I'm going to do F2, Control Shift Enter, boom, and there is only one mode. Okay, so I'm going to use then that mode, single. So look, the mode is the most common value, right? The most common salary is now $320,000. So big disparity between these three. Which one will be a better representation of the typical value? Well, in this situation, right, it may be that the median or maybe the most. Okay, now the variance. Okay, so variance here, variance.s is for samples. So I'm going to do it for a sample. Okay, so the variance is $12 million. Okay, and then the standard deviation is just the square root of that. Oh, sorry, this is the square root, right? SQRT. So 3.47 million. Okay, I could calculate this directly. So stdef.s, okay, and use the data. So same number, okay, $3.47 million. All right, very good. So these are directly from the data. Now I am going to do it from the um, table. Okay, so I'm going to do this. I'm going to copy this, Control X, Control V. I'm going to copy this guy here, Control X, Control V, right? And these are from the data in this column, and these are from the table in this column. Okay, so I can compare them. All right, so now what do I need in order to calculate first the mean? So I need to multiply The value, which in this case, right, the representative of each value in each class is the midpoint. So midpoint times frequency, midpoint times frequency. Okay, so this will be x times x times f, midpoint times frequency. I do that for all. Okay, and then here to calculate the mean, I just add them all and divide by sample size. So if we approximate from the data, from the table, sorry, the mean is, instead of 3 million point 24, now is 3 million point 42. So $200,000 difference. Not much, right? In terms of the difference when we use the table and when we use the actual data. Now the median will be the mean value. So let's see, when the cumulative frequency is about 50, so it's between these two, and it's actually closer to this guy. So it may be pretty close to the upper class limit here, right? So 2 million and change. So this looks like a reasonable number here. So let's use the same, okay, 2.2. But now I'm using, right, the way I'm uh, arguing that this is the value. Well, I'm looking here at the cumulative frequency, right? And I see that, you see, half of the data entries are pretty much less than 2 million, right? 46% less than 2 million. So with a little bit more that I go, right, I can find that the median is, about $2 million. Okay, so maybe we can use only 2 million. Now the variance. Okay, so now I have the mean here. Okay, so then I'm going to do the deviations. Okay, then I'm going to square the deviations. Okay, and then I'm going to calculate the deviation square times the frequencies. Okay, I'm going to add all those values here and divide by n minus 1. Okay, so first the deviation. The deviation for each value, right, is the midpoint minus the mean. The mean here from the table. Okay, so I'm going to fix that value. Okay, so that's the value with many decimal places. I only need 2 or 1, 2. Then I square that value. Okay, many decimal places. I don't need that many. And then I calculate this, right? The square deviations times the frequency. Okay, very good. All right, so now I copy that formula down, okay, to all my rows here. Very good, right? And then the variance is going to be adding all these guys and divided by n minus 1. So the sum of the square deviations times the frequencies, okay, divided by sample size minus 1. Okay, so 11.85, pretty close to 12, right? And then just the square root of this guy, right, is going to be the standard deviation. So 3.44 as opposed to 3.47, so pretty close. And the mode, 0.32, well, it will be, right, according to this, about 1 million, right, because this is the class with the highest frequency. Okay, so you see, these are the values directly from the data set here, and these are the values from the table. So the important ones, which are the mean, relatively close, the median relatively close, the variance relatively close, and the standard deviation relatively close. So pretty good.